Good morning, students. Praise Jesus. 10th Science, Unit 10, Types of Chemical Reactions, Part 3. Now, let us recall what we learnt in the previous classes. Introduction of chemical reactions, types of chemical reactions based on the nature of rearrangement of atoms. It is classified into combination reactions, decomposition reactions, single displacement reactions, double displacement reactions, and combustion reactions. Types of chemical reactions based on the direction of the reaction, it is classified into reversible reaction and irreversible reaction. Now, we are going to see the next topic, rate of a chemical reaction. Let us consider the different chemical reactions. For example, rusting of iron, digestion of food, burning of wood. So different chemical reactions that takes place at different rate or speed. So the rate of the reaction is important for a chemist for designing a process to get a good yield of a product. For example, you consider the following reaction. A gives B. A is the reactant and B is the product. Now, the rate of a reaction is the change in the amount or concentration of any one of the reactant or product per unit time. So, consider the following reaction. The rate of the reaction is given by rate is equal to minus D of concentration of A with respect to time, that is equal to plus D of concentration of B with respect to time dt. The symbol represents the concentration and D represents the infinite symbol change in the concentration. So, the concentration of A, B is the concentration of B. The negative sign indicates the decrease in concentration of A with respect to time. And the positive sign indicates the increase in concentration of B with respect to time. Now, what are the factors influencing the rate of a reaction? First one, nature of the reactants. Second one, concentration of the reactants. Third one, temperature. Fourth one, catalyst. Fifth one, pressure. Sixth one, surface area of the reactant. The first one, nature of the reactant. The reaction of sodium with hydrochloric acid is faster than that of acetic acid. Here, the hydrochloric acid is stronger acid than acetic acid and thus it is more reactive. Hydrochloric acid is a strong acid. So, the rate of the reaction is very fast when compared to the rate of the reaction with acetic acid. So, the nature of the reactants influence the reaction rate. For example, Na. Sodium reacts with hydrochloric acid. It gives sodium chloride, NaCl, with the liberation of a hydrogen gas. This is a fast reaction because hydrochloric acid is a strong acid. Second equation, sodium Na, it reacts with acetic acid. CH3COOH. It gives sodium acetate, CH3COONa, with the liberation of a hydrogen gas. This is a slow reaction because this acetic acid is a weak acid. So, stronger the acid and faster is the rate of nature of the reactant. Second one, concentration of the reactant. reactants. Changing the amount of the reactant also increases the reaction rate. What is concentration? The amount of the substance present in a certain volume of the solution is called concentration. For example, the zinc. It reacts with 2 moles of hydrochloric acid and also 1 mole of hydrochloric acid. Which is a faster reaction? Here, the concentration increases the rate of the reaction. So, 2 moles of hydrochloric acid, it reacts with zinc to form zinc chloride with the liberation of a hydrogen, and this reaction is very fast. So, the concentration of the reactant increases, it increases the rate of the reaction also. The third one, temperature. Most of the reactions go faster at high temperature. Here, because adding heat to the reactants provides energy to break more bonds and thus speeds up the reaction. For example, calcium carbonate CaCO3. It reacts with hydrochloric acid to form calcium chloride plus CO2 plus H2O. This reaction takes place at a room temperature. If the temperature is increases, what happens here means the speed of the reaction is also very faster. So, when the reaction mixture is heated, the reaction rate is also increases. Fourth one, pressure. If the reactants are gases, here the conditions, the reactants, what are the reactants here? Methane and oxygen, both of them are gases. So, the reactants are gases, increases their pressure, it increases the rate of the reaction. This is because on increasing the pressure, the reacting particles come closer and collide frequently. For example, methane, CH4, it reacts with oxygen, 2O2. It gives carbon dioxide, CO2 plus 2H2O. Here, if the pressure increases, the rate of the reaction is also increases. The fifth one, catalyst. What is a catalyst? Catalyst is a substance to speed up the chemical reaction and it not involved in a chemical reaction. So, a catalyst is a substance which increases the reaction rate. In certain reactions, adding a substance as catalyst. In this reaction, manganese dioxide is act as a catalyst, MnO2. And this catalyst, it speeds up the reaction. For example, potassium chlorate on heating, KClO3. It decomposes into potassium chloride and oxygen gas, but at a slower rate. The reaction is very slower one. Now, if you are adding a catalyst, here the MnO2 act as a catalyst. The catalyst, it speed up the reaction, so it increases the speed of the reaction. So, 2KClO3, here MnO2 act as a catalyst, it forms 2KCl plus 3O2. So, the catalyst speed up the reactions, the chemical reaction is very faster one. The sixth one, surface area of a reactant. For example, calcium carbonate, CaCO3. It is a powdered form and also it is a marble chips. Here, the powdered form means larger the surface area and it speed up the chemical reaction when compared to the marble chips. When solid reactants are involved in a reaction, their powdered form reacts more rapidly. For example, powdered calcium carbonate reacts more readily, fastly with hydrochloric acid than marble chips because powdering of the reactants increases the surface area and more energy is available for the on the collision of the reactant particles. Thus, the rate of the chemical reaction is increased. So, the powdered calcium carbonate CaCO3 it reacts with 2HCl to form calcium chloride CaCl2 plus carbon dioxide CO2 plus water. So the surface area increases, it fast up the speed of the chemical reactions. So these are the factors that affecting the rate of the chemical reactions. Now come to the assignment. First one, define the rate of the reaction. Second one, explain the factors influencing the rate of the reactions. These questions you have to learn and write one time. Okay, students. Thank you.